Hello everyone, welcome to Automation Community. In this session, we are going to see about Arithmetic Operation Part 2. So before entering into the topic, kindly like and subscribe our YouTube channel for more videos and updates. So in the previous session, we have seen addition and subtraction. And in this session, we are going to see about multiplication and division. So let's see about the instruction. So let's get a new PLC instruction, and for multiplication we are having this symbol. All right, so same like our addition and subtraction, I'm going to give two variants and one output. All right, so this is a 16-bit, all three are 16-bit. So just give OK, and just give one condition over here. Connect it. So D0 multiplication into D1 and is equal to D2. The result will be storing in D2. So let's go for the simulation. So now initially the value will be 0, 0. So the answer will be 0. And moreover, the condition is not true yet. So suppose if you are making the condition true, you can see 0, 0, 0. Right? So now I'm just making this to some value. Just tap on it and you can give some value. Let's say 10. So now 10 into 0 is 0, correct? So now change the value of this, okay, one more 10 here. And now if you see, the value is 100 now, right? So let's here, this is minus 10. So the answer is minus 100. Okay, so this is a live update. This is multiplication. So in the same way, we'll do the division also. So let's take the same 0.0. Let's take that here and add one more new instruction. That's for division. So for division, the symbol is this one, slash, front slash. Okay. So now I'll give a different set of address, D3, D4 and D5. So just go for the rung connection. Alright. So just go for the simulation. Now all the four instruction, like the addition, subtraction, multiplication, division, all three are for integers. Okay, this is for 16-bit addition and subtraction and multiplication and division. All right. So now if you see, okay, so there is one concept over here, and this becomes a 32-bit. Okay, so if you see the D over here, no, that is nothing but a double. So whenever you are doing a multiplication, the result may be, it may cross 3267, the highest value, this value 32767. So for that they have made that as a double integer. Double integer means that will be the 32-bit. So that's what you can see the D here. And since I have used D3 here, you can see some, instead of 0, there is some value over here. This is minus 1. That means what? As I have already told you in the previous session and even in the beginning of this session, D0 is nothing but a 16-bit register. Correct? D1 is a 16-bit register. When you want a 32-bit, what you have to do? You have to combine D0 and D1. Alright. So that's what, see, if D2 is a 32-bit register, D2 and D3 both are combined, right? That's what you can see some default value in the D3. Okay. So it should be a 0. But since I have used D2 as a 32-bit here, I'm having values over here. So what I have to do, I have to change the address here. So what I'm going to do is make this as D4 D5, and this going to be a D6. So let's go for the simulation. So now the result word is word only, 16-bit only. This D6 is the 16-bit only. So there is no D over here. Look at this. So let's turn on the input. So give some value 100 and D5 is 10. So that 100 by 10 is 10. You can see the quotient here. This is the quotient. Alright. So 10 by 100 by 10 is plus 10. This is the quotient value it will show. Okay. So what if you want a decimal, you want to, deal with the decimal arithmetic operation, not decimal, sorry, it's a floating point, real arithmetic operation. So far we have seen that integer, right? So you can give this much value and this much value, and there are some range. So what if you want to deal with the real floating point? For example, here 10 by 10 is 100 by 10 is 10. Suppose you give 20 here, and here this is a 3. So what is 20 by 3? It may be 6 point something, right? So it is a, fraction. But now if you see the result is 6, it is giving the quotient, correct? It is a quotient value. So you want the value like 6.666, like that means you have to use a different set of instruction. This is for integers, for 16-bit. So if you want to use it for the floating point means you have to use a different set of integer. So I'll show you that also. So let's make the same input here. Go for D10, go for find instruction, and you can see there is a option for floating point. See, there is a floating point, and here you can see division, multiplication, addition, and subtraction for floating point numbers. So now I'll take division, and I'm going to give D4, D5 and D6. Same value I'm giving. Okay. Okay. Since it is a 32-bit, I have to give like, I'll take some other value. So I'm giving D10. So D10 and D11 is for the first one. So I have to give here as a D12 and 12 and 13 for this, and I'm giving D14. Alright. So it I have taken now. Since it is a 32-bit. So previously I have told no. So let's give the value as 20 here, and it will be taking the rest 20.00. Since it is a floating point instruction, it's taking like that, and you can see the range here. How much range you can give. See? So 20 by 3. Now you can see the answer will not be only 6, but you will get the exact decimal value. Look at this, 6.66666, and it is round off to 7. Alright. So this is the floating point instruction for division. The same thing, if you want to multiply two real numbers, two floating point means you can use multiplication instruction from floating point. That particular instruction you have to choose. Alright. So this is an arithmetic operation instruction in Omron PLC. I hope you have understood the concept. Kindly like and subscribe our YouTube channel for more updates. Thank you.